Hello, this is our regular Falsi method in Excel. So start start it. To start with, we have allotted blocks for the main equation, which would be located in the block D2 up until J2, which is a third degree polynomial equation. Next is we allotted the blocks also for the x positive and x negative values. After that, we have allotted the blocks for the table for the iteration table itself. In this case, we began with iterations 1 and 2, mainly because the table contains the x negative values, f of xn, which will be yielded when the x negative value is substituted here in this equation. And then we have the x positive values, the f of xp, which is yielded the same way of f of xn, only this time we use the x positive values to substitute in the equation. Next would be the x new value, which is acquired using the formula xp minus f of xp times xp minus xn all over f of xp minus f of xn. And then lastly, we have the f of x new value, which is yielded by substituting the x new value in the equation. In the second iteration, however, we have set the formula to work to cope in with the unique way of the regular Falsi to transfer the x new values to either the xn or the xp values. In which case, we have set an if-then statement wherein if the f of x new is a value less than 0, it will automatically transfer the x new in the xn block and the f of x new in the f of xn block. And when the value is greater than, it will automatically transfer the x new in x positive and f of x new in f of xp. So, to show you how the code works, I am going to change the equation values, also the xp and xn values. Say this will be 23, this will be 21, and this will be 25. This will be 43, for example. We'll also change the x positive and x negative values, such that the x positive will be 4 and the x negative will be -3. Notice how the table changes its values. And then since 2 equation was not enough to reach an approximate value of 0, you can just copy the whole 0 row, the whole second iteration row, and just drag it down up to any number, just for you to find out how many iterations it actually takes before you can yield a value of that is approximately 0. In which case, it took up to the 63rd iteration or even the 62nd iteration to yield a value that is approximately or close to 0. So that would be all. Thanks for listening.